In this tutorial, we'll introduce a little more complicated example. Once again, we're going to be plotting lines. We'll do a quick review of algebra with function notation, but how do we combine multiple plots into one figure? To plot a straight line, remember, is nothing but having 2 points. Whether it is a horizontal line, a vertical line, or an oblique line, all we need is an XY starting point and an XY ending point. Those 2 points can be hard-coded values. For example, the 4 will be associated with the 5, the 7.7 with the 9, and MATLAB will draw a line between the 2 XY points. However, they can be based on previous calculations. Maybe the X's are hard-coded and the Y's are calculated. So in other part of your code, you would have an equation for V1 and for V2 values. Or they can be entirely derived from a usual line equation y equals mx plus b. In that case, notice the absence of brackets. MATLAB automatically knows to go through your x's and calculate for each x value a y value that's associated with it. A little algebra review first. When we talk about functions, we are used to seeing y of x equals x squared, y of x equals sine x plus cosine x over x, and so on. This means that one variable depends on another. In these 2 cases at top, the y variable, the value of y, depends on the value of x. If you choose an x value and plug it in on the right side, you get the value of y. In no way does the parenthesis on the left side of the equal sign is a multiplication. This just represents mathematically that y is dependent of x. In the last one, f, the value of f, is dependent on not only a 3D coordinate but also on time, x, y, z, and t. So the value of f is calculated using x, y, z, t values. F is dependent on the others. Now that we've seen all this, quick review. We're going to solve an example where we have 2 aircraft flying towards each other, unfortunately. One's heading is 40 degrees, aircraft 2's heading is 290 degrees. Aircraft 2 departs 100 miles east of number 1. We do not know their speed, so one way that we can solve this is graphically. We can draw the 2 lines and see where they intersect. That way, we'll be able to deduce at how many miles both aircraft should be extremely aware of their surrounding. A quick diagram will introduce not only the given, the find, but also the theory. First, aircraft 1's heading is known. Aircraft 2's starting point, but also its heading is known. Those are our 3 givens. To find the XY coordinate of the intersection will help us eventually calculate the 2 distances at which we will be careful when we fly. The theory is nothing but the equation of a line, with m being the slope and b being the y-intercept, but also the distance formula. When applying the theory to aircraft number 1, you can easily see that the b-intercept is 0. It crosses the origin. The slope, however, is the rise over the run, so little trigonometry brings us to y1 of x equals 1 over tangent times x. So again, y is dependent, the value of y is dependent on the value of x based on that equation. For aircraft number 2, it's a very similar theory, except we don't know the b-intercept. Notice it does not cross the origin. However, it does cross one point that we know, which is the x-intersection. By plugging in the 100 value into the x is equal to 100, we know that the y is equal to 0. Therefore, we can easily solve for b. In that case, after substituting and factoring, we end up with a similar final equation of the line. As far as calculating the distances d1 and d2, we do have x and y read off the graph once we plot it, So it's a matter of just simply figuring out the distance formula on both cases. Before you jump into coding, absolutely solve the problem by hand first. This doesn't necessarily mean plugging in all the values. When you have a graph, try to do it to scale. Here I can easily read that the x and y intersections are probably 24 and 28. The distances are roughly 37 and 80. While this is approximate, everything is to scale, so I have a very good idea of my values. With the algorithm, remember to be general. Once you have your outline set up, coding is a matter of just knowing the syntax, but you need to know the steps you're going to have to follow in order to solve the problem. The first thing we'll have to do is to define all our givens. Which variables need to be given a value so we can actually solve? Define the vectors of xy coordinates. First, define the x's. Now remember, this is MATLAB, so now we're thinking about programming. If I want to plot a line, I need vectors. So I'll need a vector for the x's. And I'll need two more vectors, one for the coordinate of line 1 and one for the y coordinate of line 2. Once I do this, I can plot both. We will introduce how, of course. Read the intersection and then calculate d1 and d2 using the distance formula. This is exactly how I solved it on paper, but now I'm taking it to MATLAB. So the first thing that I do is paste my algorithm, Control V. There is a shortcut to actually comment to everything, Control R. To find all the givens, angle 1 was 40 degrees, angle 2 was 290, and the distance was 100. If you remember the plot, the only x coordinate that we need is the origin and that 100 intersection. So x equals 0 and this 1. I did not type 100. Then what would be the purpose of having this line? The reason of this line is that this one can vary. Maybe I want to solve 200 now. Make sure you use the variables that you create. Time to create our y values. Since I am using the equation of a line, I will not need brackets. All I do is code the equation. Now there are two lines, so I do need a set of y1s and another set y2s. Again, notice the lack of brackets. MATLAB automatically creates a vector because x is a vector to start with. And notice the lack of parenthesis x on the left side. We have moved on from math to coding. The only thing on the left side of an equal sign is where you want to store your variable in memory. It has nothing to do with mathematical notations. However, y is very dependent of x here. Plotting both. This is where we start having an issue. If we use the knowledge that we have, this is what we'd be tempted to do. X, y1, x, y2. But when I run the code, notice the only line that shows up is the second one. So x, y2. Did x, y1 work at all? Let's comment it out. When I press F5, you'll notice that nothing happens. This is because I didn't follow directions and did not put close all at the top. But if you notice at the bottom, there are still two windows of MATLAB open. My script file, but also the figure. Since I did not close the previous one, MATLAB reused that plot. However, now plot xy1 shows up. So both work, it's just a matter of putting both on the same figure. You want to hold on to the figure above. So what we do is introduce this hold on command in between the two. More importantly, underneath the one you want to hold on to. Even if I was plotting multiple plots below, I only need to write this once. I want to hold on to the first one, imagining you grabbing that first plot and holding on to it for the rest of the code. MATLAB will pile on top of it everything below. Since I don't want to go get my figure every time, I will do close all. This will close all the figures and reopen a brand new one. So by doing the hold on command, it is the first method to combining multiple plots on the same figure. The intersection is a little bit hard to read, so I'll introduce grid on. Better. Now I know it's between 2030 and 2040. There is still a zooming option available. 23.5 and 28. That works. What I wrote is true. Every time you run your code, you're going to have to change these values. No worries, we'll soon read input command, which allows us to ask the user to enter what he read, and this will make the code perfectly fine for any kind of planes flying in those directions. But for the time being, let's see if we can calculate D1. And D2 equals So not only does the plot pop up again, but D1 is equal to 36 and D2 is 81. If you remember me solving by hand, that was very close to what I had. So I'm comfortable in thinking that my code is properly coded. Let's finish making this plot professional. Title, aircraft collision. If we print it in black and white, would this be professional? You wouldn't really know which aircraft is which, so let's introduce a legend. Remember to use the single quotes when we're coding strings. MATLAB automatically knows that the first word that I type here is associated with the first PLOT command, the second one with the second one. Let's also introduce some line specifier, diamond, dotted. So now we could print in black and white. We would be able to see what aircraft 1 and aircraft 2 is. I didn't add the colors because in the second method I'm going to show you, the colors are automatic. And it's actually shorter code. I will delete all the way from the X to the parenthesis and replace all that by a single comma. So all I'm doing is putting XY line specifier, XY line specifier, XY, and so on as much as I want. But the one big difference is that MATLAB automatically rotates through the colors. So notice the second aircraft is green. Blue is the default, green is next, and I think red is third. Last. Miles. There you go. If I change this to 200, they intersect now at 46. Let's do one more. 46, 8, 55, 8. There, so now the distances are 72 and 163. Always test your code multiple times to see if by mistake we didn't put 100, for example. Me, by mistake, I could have gone too fast and left 100. My values would look wrong. But that concludes this tutorial. I've shown you two ways to plot. The key points are to always define vectors for x's and for y's. There are two possible methods to combine plots. Either the hold on, remember to only type it once, underneath the first plot you want to hold on to. Or if you want the advantage of MATLAB going through the colors automatically, plot x, y, x, y, x, y. It's always by pairs, and if you want to introduce the line specifier on top of it, why not? Remember that when printing black and white, this is useful. The line specifier need to be there, diamond, dash dotted, and all those. Using a legend will add professionalism to your plot. Using grid on will make it easier for you to read intersections.